Okay, so we first start with the, actually exactly with the rxout file, because that's one of those kind of files which is very comparable, that one, what you would do in Excel. So first, let's just open it, and then I will tell you what is inside that file. So you will click on in the environment and click on the import dataset. Oh, sorry. Let's just start with the ggplot, because we haven't, if someone hasn't installed in ggplot yet. The way how you can install, you can go up to the menu and tools, install packages. And here you just write in ggplot2 and say install. I have it installed, so I won't update my package. I will update. So as you can see, as we spoke about dependencies a few meetings before, the RStudio or the ggplot package actually has quite a lot of dependencies as well. So I only plan to install ggplot here, and I only asked RStudio to install ggplot, but it is depending on some other packages as well, and that's why all these packages were installed. We will also need the reshape2 package, which wasn't installed, so that's another thing. So please go up to the install packages and write in reshape2 and install. Is there anyone who has problem with installation at this point? Or is it going well? Okay, if no one speaks, then it means that it works well. Okay.
Hi, Osh.
Yes.
Sorry, I'm getting a message coming up saying, do you want to install from sources the package which need compilation, yes, no, or cancel?
I guess if you say yes, then maybe it will need something else. Just try to say yes. But can you imagine that we have to install something else as well? If you get an error message.
Trying. I think it's working now.
Okay. We will see.
Yeah, thanks.
Okay. Did you get back the console? Like this, so you can, is it finished?
Still going through, I think.
Okay.
We could just move on and I can let you know if it doesn't work.
Okay, okay. Okay, so the two most important things we have now, the ggplot and reshape packages. So let's load them in. So when you install a package, it's not loaded into the environment automatically. So you have to load it in. You can do it in two different ways. The first is if you go to packages here in the lower right corner, then you can find ggplot, which is here. For me, it's already loaded because I worked on figures today. But if it's not ticked for you, just tick it. But in the same way as it is now written in your console, you can just copy this whole line into your R script. So when you know that this R script, what we are working on, will contain mostly plots. And if you want to go back, so what I'm doing, for example, I'm doing one R script for one paper, for one manuscript, and all the figures I'm making with ggplot or with R, they will be all in one R script. And in the beginning, I'm always loading in the required libraries. You actually don't have to do this long. It's just enough to say library ggplot2 and library reshape. So, and just command and enter. So from this point, they are all loaded in to the environment. So we can use their comments. Is it working for everyone? If not, please stop me immediately, because then there is no point to going forward. Okay, I will put the chat. Oh, there's no chat. Here, if someone writes me there. Okay, so let's load in that infamous rx out file. So it will be probably on your desktop. If you save it there, rxtemp.out, that's the file we want to load in. So when you load it in, the first thing you see is that R is trying to find out what is in the file, how it has to be separated into columns. And this one actually is automatically separated by the tabs, so that's good. There is no header in this file. This is very important. There is no header, so R will generate an automatic v1, v2, v3. It's like variable 1 and variable 2 and variable 3. That's not a problem. We will introduce, we will make a custom header. And it will be imported into a data frame, which is the best working variable type in our case, especially if we want to do some plots. So we don't have to do anything. If you have a header in a file, which we will see in the next example, then you have to say that yes, we have heading. If we say here, then the first row will go into the header, which we don't want, of course. So just say no. And you can also change the things here if you don't use tab. Okay, so I will show the Tom again. So in the upper right corner, if you have the environment tab active, then click on the import dataset and say from text. And then navigate to that place where you save this file, which is on my desktop. Okay, so we don't have to do anything with this, just say import. As you see here down on the bottom left corner, this is how you do it actually. So it will be pumped into the rx_temp variable, which will be a data frame. And this is how R reading in a table. So again, if you want, also with the view command executed, you can also see what is inside this data frame. But if you want to save this again for the future, because maybe you will change your input file and you want to read it again, you just simple copy from here and paste into your R script. And if you change your input file, then you can read it in with a single command enter later. So what do we have here? This is the log output. Someone was there someone asked something? No.
I think it was just something in the background.
Is it yours, Seb?
No, but there was some noise in someone's background, I think.
Yeah. Right. Okay, let's go forward.
I think it's JF514. I don't know who that is, but that's the person speaker that is on.
I'm sorry. Let me see. Mute.
Okay.
Okay.
Marta is the cruel admin, muting anyone she wants. Right. So what we have here is the output of a replica exchange simulation. So it's actually the work which I'm doing with Thomas recently, who is here in the audience. what is replica exchange simulation? So if you would like to find out how protein structure changes with temperature, how a protein unfolds, or how protein chain goes into the normal folding state, like a domain, how a domain takes its three-dimensional structure, then you can do molecular dynamic simulations. And replica exchange simulation is a special simulation. So in this case, what you have is you have 8 different temperature boxes with very low temperature to very high temperature. The very low temperature is usually way below the room temperature or body temperature, what you should where you should have the normal structure of a protein, and the highest temperature is always much higher than the normal temperature. So your normal body or room temperature should be somewhere in the middle. The way how you do the replica exchange simulation is that you put one protein structure into each box, and with time you are replacing these structures from one box to the other. So what is happening during the replica exchange simulation is that a protein has a chance to be in a high temperature box where it can take up a lot of energy from the environment, and it can unfold. So it's the same as you would like simply boil a protein, boil like an egg, which will of course coagulate. And the protein also has the chance to go into a lower temperature box where it has time to relax and time to give the energy to the environment and take up some kind of folding. And the reason why we are doing this replica exchange simulation is that instead of heating up the protein and cooling down and heating up and cooling down, is that by randomly changing the environment around the protein, we give the chance for the structure to walk through the whole conformational space. What the conformational space is, that space that is the ensemble, all of those structures, what the same polypeptide chain can take. So let me just turn off my what's up. So I won't go into much more detail now. The question in this case, and this was just the very first run of our replica exchange simulations, is that if we have 8 different structures, do they really go into each boxes, or they tend to stuck into one of those boxes? So it's much more about the question about how this exchanging happens. So if you just go and look at the table, the first column gives you the step number. So this is the initial step, and this is after 1,500 steps, and then after 3,000 steps, and so on. So we are reporting their presence after every 1,500 steps. And what you see here is this is not a real temperature. This is a relative temperature between 0 and 1. And 0.54 is a relatively low temperature, while 0.71 is a relatively high temperature. So we have all the 8 different structures in the next 8 columns. And as you can see, this one, V2, started in a very low temperature box, V3 higher, V4 higher, and so on, and V9 was in the highest temperature box. And if you go down, you can see that, for example, V9 went into a much lower temperature with time, but actually it is not really going down too much. But I don't want to see this with my eyes. I want to plot a line graph which shows all the 8 structures with time or with time step, what we have in the first column. It shows us how the temperature environment changed around the 8 different structures. So it will be a simple line graph. On the x-axis, we will have the time step. On the y-axis, we will have the temperature, and each line will go up and down with time. Before we start plotting the data, I want to make a much more descriptive header. So how you do this is and again, it's just simply you write into Google how to add header to dataset in R, and first link in Google will go take you to the Stack Overflow help page where someone else already asked these questions, and this is what we have to do. So we have to use the call names. I will put it here. The call names function, call names rx temp. We have to give a vector. So as you already know, it is starting with a C. This is how you define a vector. And you just simply give that 9 words you want to see instead of V1, V2, V3, V4. This is 9 columns, 9 words. So the first can be the time step, and then structure 1, and this will be 2, 3, 4, 5, 6, 7, and 8. If you don't have the word wrapping turned on, so if you go out to the right hand side here, then I think the word wrap, not here, RStudio preferences, code, and you have here the soft wrap or source files. If you have to tick this, and if you tick this, then it will make a new line automatically. Okay, so this will be of course 2, and this will be 3 and 4. And if I run this, then my RxTemp data frame changed already. So we are having the time step header, and we are having the structures headers as well. So this is how usually you collect data in an Excel file. But this is now not the format how ggplot likes the input data. In ggplot, what you usually have is you have the time step, you have the temperature, and on a third column, you have an identification that it was in structure 1. I will show you how it looks like, because this is what we are doing next. So we will use the melt function, which is, I think this is why we have to include the library reshape2. Yeah, if you can see here down on my help window, the melt is actually in the reshape2 package. So let's just call it rxtemp gg. It's like for ggplot, and we are just simply say melt rxtemp. So we will change rxtemp, and we will pump it to rxtemp gg. let's see how it looks like. So just click on it. It's not perfect yet. Yeah, this is what we wanted. Okay, so you have to give that variable or that column identifier what you want to preserve as your x-axis. But instead of having multiple y values, you will always have one y value in one line. So you have one x, 0, and one y, 0.55. If we just reorder this and see, we have all the time step zeros for structure 1, 2, 3, 4, 5, 6, 7, and 8. It seems that we need to see, because without C it didn't work. Okay, so now we are in that structure, what we have to put into ggplot. So you have in one line only one x and one y value, and you have an identifier on which structure has these two numbers. Okay, so the good thing with ggplot that it's nicely modular. So if you start making your graph, you are just giving new comments, new pieces to the whole picture, and it will be nicer and nicer. The very basic thing what all ggplot plot starts is to say, of course, ggplot. I'm continuously pushing some wrong button. We are using ggplot2 library, but actually the function is ggplot, not ggplot2. We will give the first parameter, which is the data. You can also say data equals to. Again, something happening in my background, I don't know what. Right, okay. Which will be our rx temp gg. So that's the input data. And then comes the aesthetics, which is always starts with AAS. And then in, what am I doing here? Okay, it starts with an AAS, and then in brackets, we have to give what we want to put in to the X and what on the Y axis. So we will put the X will be the time step. So just give the column identifier, time step, and the Y value will be the value which is changed to value. This is the basic. If I run this, nothing will happen because we haven't said to ggplot what kind of graph we want to plot. So we want to do a line plot. So we will just say geom line. I think I have a problem with one of these updates I did, and it is going in my background continuously. That's why I have these. Yeah. Let me just load all the packages. Unload all of them at the same time. Sorry. There wasn't any problem for me during the whole day, just now, because I have to show it to you. Okay, I think that was the last one. We will see. If I have to close the RStudio, I will close the RStudio. If not, I will try. Okay, I will just try to clean up this one and clean up my environment as well. And now I will get in, read in this one, do the same thing, and here we are. Okay, geom line. No, something is wrong here. Read tell in which we used. Okay, let me just restart my R. Something is wrong with my R. Let's see what's happening. Okay, now it is loading in. I can give the column names. That's why it is always good to save everything on your R script, because then you just go back. Okay, let's try it. Just simply say geom line. This is the way how you can ask ggplot to do a line graph. I don't think it will work. Of course, it's not working. The problem is, I think we have too many lines on the graph at the same time. We haven't set to the ggplot yet that we want to draw one line for structure 1. We want to draw one line for structure 2 and 3 and 4 and so on. So here we have to say group equals to, and this was our variable. So let's group the data. Let's group the input data according to the what is in variable. Wasn't it variable? Oh. It is called variable, but then I will, maybe it messes up with something which is also called variable. So let's just simply rename the columns in X temp gg. We can have the time step, and we will have the structure ID, and we will have temperature here. It will be time step. Structure ID and temperature. Okay. Now it has new column identifiers, so we will have the time step, we will have the temperature on the y-axis, and we are grouping them by structure ID. Much better. The problem is that we don't see too many things because everything is black. So we want to color them as well. We can say it, I think, here, but we can also say it here. Color equals to, and I'm not sure that this is the structure ID works here like this. No, because we have to say something like this. Of course, it's not a color name. Okay.
Lajos,
Yes.
you have to put it into AES.
Oh, I didn't put the ID.
No, before color, it needs to go AES and then
Okay. Thanks. It's okay. It's a little bit better, but not much better. The problem is that, of course, we have huge amount of data here. So what you can do, you can click on the zoom button here, and then you will have a much bigger window. But what we already see is that certain structures doesn't go down really too much. So what we see here is that red, which is structure 1, okay, we can't really see it. Okay, so we have to look for a little bit different way of making graph from this. Okay, it's not a problem. The second thing what we can do is that we are plotting the distributions of temperatures for all structures. So instead of making a geom line, we will do a box plot. But we won't really looking at the time this time. Okay, let's just leave it there. It will be a different one now. I want to make a nice graph for you. And it turned out that it's not the best. Maybe we can just simply reduce the number of the amount of data we will have here. Okay. So now what I will plot is on the x-axis, I will have the different structure IDs. The y-axis, we will have the temperature. The easiest way is to just simply plot them with dots first, which is the geom point in ggplot. And you will have a lot of dots, a huge amount of dots. Of course, many dots are just simply on each other. So we have, I think in this file, we have a few thousand data points, but because we have so many data points on each other, we can't see them now. That's why we should do something else. Instead of making a geom point, we can make a geom box plot, which will give you the distribution much better. And what you can see here, and this is already giving us some biological relevance or some bioinformatics relevance. So as I told you, the aim in replica exchange simulations is that all structures should be in all boxes during your simulation. That's where you will get back the best results. So something what we see here, for example, structure 8 and structure 7 and structure 8, they are those structures which were put into the highest temperature box, and it seems that they stuck there. The reason why they don't change is because probably the difference between the temperature boxes are too high. So when I will repeat this simulation, I have to put these boxes a bit closer to each other. It's interestingly that, for example, structure 5 went through all the temperature boxes nicely, but also if it goes down to one of the low temperature boxes, it seems that it likes to stuck there as well. So I have to, in my next simulation, I have to increase a little bit the low temperature and decrease the high temperature and put the temperature boxes a bit closer to each other. Before we go on to other different graph types, Of course, this is not how a nice graph looks like, because you have very small labels. Maybe you don't like the gray background. Maybe you want to make a bit more colors. So what you can see, and this is where the ggplot modular okay. I don't know why my chat window disappeared. Okay, it's now here. Ah, okay, that was the problem. Thanks, Chioma. Next time I will have the chat window here. Okay, so for example, you would like to change the background and having some kind of more conventional graph type. That's the easiest way to do with the built-in themes of the R. So if you go on again to the ggplot website and look for the documentation or the reference here up this link and go to themes, then you can see that there are many different themes: gray, black and white, light, minimal. You can just try them. So just simply say plus theme BW, which is the black and white theme. And if you say Command Enter, it changes to a different style. So this is where you can start if you want to make your graphs a bit different or a bit nicer, or just closer to your preference. And as soon as you decide what is your base theme, then you can go on and change the labels, change the sizes, or any formatting on labels. So let's just, for example, give a new X label, because it's not nice to say structure ID there. So this can be done by the xlab command. Again, it's just simply a plus here. So we are working with exactly the same thing what we were before, but we are adding or modifying something. So the X label is of course automatically came from the variable name or the column identifier we used, but you can say anything here. So protein, say protein structure ID, which is a bit nicer than just saying structure ID in one word. And now the X label changed, but it's not really nice because it's too small. Again, the temperature is also too small. So let's change these things as well. And this is again happening with the theme command, but we don't see any theme underline and something. The theme underline something is therefore changing the basic theme. But if you want to change something within your plot, then this is how you can do. And this looks a bit weird, to be honest. But again, if you don't remember, just go back to one of your previous plots or just ask Google, and it will help you. So let's first change the character size and make them bold for the X and Y labels. Usually you should use the same character size for X and Y labels. So what we will do is say axis.title. If you want to change X or Y, then you can say here, as you can see in my help, you can say axis.title.x or axis.title.y. But if you want to change them together, then just simply say axis.title. This will be equals to an object, which is element text. I know it's a bit weird. For me, it took quite a long time. But again, you don't have to memorize this because everything will be here. Everything is always there if you ask Google. And here, within these brackets, you can say that if you want size to 14, and this is the same kind of size what you would set in your Word or PowerPoint document. And you can also say, for example, face equals to bold, and it will be thicker then. So as you can see now, the labels are much better. But now I think the axis text, which is a bit too small, but it's not a problem, because here within the theme, you just make a new definition and say axis.text. Again, you can define separately the X and Y if you want, but we are changing them together. And it should be, again, equals to an element text object. And we want to set it to 12. Of course, what is quite often happening when you are doing a box plot and you have your factors, you have your identifiers on your x-axis, they are now too big and they are overlapping each other. So what you can do, you can just simply angle them. You can angle them any kind of degrees what you want. And as far as I remember, but I'm not sure that this is working like this, but as far as I remember, so we are just trying to change the axis text X now. So instead of changing the X and Y together, now I'm changing only X. And I think I just say angle equals to 45, maybe. No. Oh yeah, I have to say element text, as always. And yeah, it is there. But now it is going, so that it was rotated around the center point. So that's why the left-hand side went down and the right-hand side went up. So what we have to do, we have to also push it a bit down. Otherwise it will go into our plot. And this is done here. So we are just modifying the axis text X. So only the x-axis text, which we angled and which we have to, I think it's vertical. Okay, let's see what we have to do here. Rotate axis text. ggplot. I think it's vjust or something. Justification. Usually when, yeah, it's the same here. Oh, it's horizontal just or vjust. I think it's actually what we will see. Yeah, so we pushed it down half. So the half means that it's, I think it's relative to the whole height of this box. So just imagine this as a box. It's a square box like this. And now we pushed it down with half of its height. That's why it's 0.5. So I think if it's 1, it will go down. No. Okay. And just accept that it is done by like this. Okay. If you want to introduce some colors, you can make the boxes in different colors, but I don't think it's extremely important for this kind of graph type. But you can do it, I think, here again with the same kind of aesthetics, saying that color equals to structure ID. It will be different. You can also set your own colors if you want. So you can say that because this is a color, so you can say that I want to change the color, which is a scale, as far as I remember, scale, color, discrete. The scale color continuous comes into the picture when you have, for example, a heat map, and you have a legend where you have a color bar between red and green colors, and you can define different heat map colors with the scale color continuous, for example, or the gradient much more. But here we have discrete values. We have 8 discrete groups. So this is what we will use. And the way we have to do this, I think it's just saying values, as far as I remember. Will be equals to a vector. Let's just try with red and blue first. If you give less than values than you have, so I only gave 2 colors and I have 8 categories, and I think then it will be just repeated simply. No, because the values is not what I should use. Let's go back to the our ggplot and look for scale color discrete. Was it there? Continuous. Oh, maybe it's manual, it's not discrete. Oh, yeah, I think it's manual now. And it has to be palette. Oh, it's scale color manual. Oh, yeah, okay. I think that's just a simple. No, it won't be repeated. So there's an error that I gave insufficient number of colors. So instead of finding new colors, I will just, let me just copy this 8 times here. So now we have red and blue changing. The good thing with R that there is a lot of colors built in you can choose from. So you, again, just use Google and look for R color palette. Look for any of these figures here. Maybe this one is good. So these are all the colors you can choose from. If you want a bit more darker red, then you can choose red 2 or 3 or 4. For the same for the blue, there are many different grays. You can always give it with the hexadecimal code as well. So that's the other thing what you have to have open when you are doing any kind of graph is the Color Brewer website. So I will just open a new one here. This is the link. I don't know if you can see because it is covered with the Zoom header for me, but that's the Color Brewer 2. That's far one of the best sources for choosing colors. If you want diverging colors, you just change the diverging here, or qualitative colors here. You can also click here the colorblind safe colors. So this one shows it's a colorblind safe, which means that if you use these palettes, these colors, you can choose 5 different colors. It is questionable now that I gave another color, but up to a point it will be colorblind safe, which can be an important factor when you're publishing figures as well. And here you don't have that kind of R built-in color code, but you have these strange color codes. But it's not a problem because it's also understood by by R. So what you have to do if you like, for example, these, let's just go for the 8 different colors, because we have 8 different colors. You can also say export and just simply copy this. It's not in R format, but we will reformat in R. Just simply paste it here, and it's almost the same as we have here, but instead of square brackets, we need simple brackets, or we even don't need the brackets. Just copy this string of numbers here instead of red, blue, red, blue, red, blue. Okay, so this is also recognized by R, recognized by ggplot, and if you hit enter now, then you will see that it's nicely getting that color scheme what we saw on the color brewer side. The way how you change the color is changing by what kind of plot you use. So if you, for example, use a bar chart, then you have to use scale fill, not scale color, because it has to be filled in. I think we can also fill in these ones, but if we fill in with colors, then we won't see the median value. So I think it's not a good choice in this case. You can also put on this graph the individual data points. It will be quite crowded, but it's a good way for practicing. So what we want to do is, instead of using geom_point, what we saw that the geom_point is problematic if you have the y values exactly the same, because then you will just put hundreds of points on each other. So instead of using geom_point, we will use geom_jitter. It's also a scatter plot, but it automatically pushes dots away from each other, which is not always good. We don't want to push them away from each other vertically, because we want to keep them in the same temperature range. But it would be nice to push them away horizontally. So again, I used this function a quite long time ago, so I will go back to my ggplot and look for the geom_jitter function. So what you can do here is you can, so this is how it looks like if you have geom_point and everything on each other, and the same thing with the geom_jitter. But what I want is to say how far I want to push them away, and I don't want to make a vertical push. So I think the height should be 0, but we will see. So what we have to do is we have to give, I think, the aesthetics. No, maybe not. Let's just try it with this first. Ooh, yeah. So clearly we have a temperature somewhere in the middle of these big blobs, and it is pushed away in each direction. Okay, so first of all, let's set the height to 0. Yeah, they are not pushed away anymore. Clearly they are too big, so let's make the size of the dots much smaller. Let's say, I think 1. We are quite small dot, not small enough. Yeah, these are very small. Let's let it a bit push away, but not too much. So let's go for like 0.3. So we can see the temperature range at least. No, I didn't want to do this. Probably it's not relative, but it's depending on this one. Yeah, Okay, 0.01 then. It is taking up the y-axis. Values, okay. Not extremely nice, I wouldn't say, but it's a bit better. You can also make it transparent. So you can say alpha equals to 0.2, which means that instead of having a black dot, you will have a 80% transparent black dot. And it's now a bit better. And what you can see here is that really structure 8 was mostly in the highest temperature, structure 7 was mostly in the second highest temperature. Interestingly, structure 6 went down. Structure 6 started somewhere here and then went down and stuck here, but it's relatively well distributed. But clearly, the upper 3 temperature ranges are quite hard to reach. And if it's reached, then structures tend to stuck into that temperature box. You can also use these very weird ones like the violin. I think the violin plot is there as well. I don't know if it is called violin. Yes. So the violin plot is changing its thickness based on how many dots or how many values you have in that place. So instead of the geom box plot, we can use the violin here. It will be a very nice plot. This is what I would expect. This is what I would like to see, what structure 1 shows. Not exactly because the upper 3 temperature ranges were never reached by structure 1, but if I only look at the first 1, 2, 3, 4, 5 temperature boxes, it seemed that it was relatively well distributed between these temperatures. So what I have to change when I will next run this simulation, I will clearly have to bring the top 3 closer a little bit. This looks also nice for that 4 temperature ranges only. Okay, let's go and do something else and import our other data set. So we have the yeah, I know what we have. Okay, so the next should be this supplementary data txt. I don't know if I have it on my, yeah, I have it on my desktop. So here, if we import it with the graphical user interface, interestingly, the GG or R doesn't really recognize that we have a header. So it wants to add v1, v2, v3. Well, we have a header in this text file. This is again a tab separated text file. So we have to click to the heading yes, and now nicely all these headers are going up to the data frame header as well. And you can also change the name of the data frame. So let's just change it as the df as supplementary data frame. It will be much easier to write it in because it's a shorter name. So again, it is imported. It will come in slower because it has 6,000 lines and almost 20 columns. Again, we have here the command which was used to read in the file. So I will copy it and I will paste it here if we want to change it and if we want to read it again sometimes later. And so this is a data which is one of our final data from our metagenomics assemblies. So what you see here, this is actually the conventional organic farm study. So here you have a farm ID. The farms are named after if it's a conventional organic farm. CV stands for conventional, organic is for organic farms, or OG. We have 5 farms, 5 conventional and 5 organic, and we had 10 samples from each farm. So CV3_2 means it's the second sample. It is coming from the second sample in conventional farm 3. We have, of course, the farm type written here separately. If we want to plot it according to the farm type, we have the clade number, because these are all already went through a taxonomic analysis and the pairwise distance check. So what you see here is one assembly, one multi-FASTA file, a collection of DNA sequences, what we think belongs to one bacteria. And as you can see, clade 97 can be found on many different farms, mostly in conventional farm 3 and 4, but also in conventional farm 2. So these first 6 samples, first 6 assemblies, sorry, which belongs to clade 97, they are probably the same bacteria. Here you see how big is the assembly. They are probably not complete assemblies. How many contigs we have, so how many separate DNA fragments we have. What is the N50 value, which is the size of that contig, which is the smallest to give to reach the 50% of the size of your assembly. So if your assembly is 254 kilobases, then there is an almost 3000 base pair long contig, which is the smallest required to put together with all the bigger contigs and giving up at least half of the size, or exactly half of the size of the final assembly. What we have here is a coverage value. So this is how deeply this assembly was sequenced. What is the average coverage on each contig? Here we have a GC content. This is usually quite important in prokaryotes, especially as you can see that for the same 97 clade, the GC contents are very close to each other. But if you go down to the next clade, which is 133 clade, the GC contents are a bit different, except these two. And then we have the taxonomical identification here, which is a bit longer than what you can see. But this is what is the domain, what is the phylum, class, order, and then I think we have family and class, not family, and genus and species as well, if we can identify. But also we have here all the antimicrobial resistance genes which were detected in these assemblies. This is not very important at the moment, but you can see that if it's 0, it wasn't there. If it's 1, it was there. Let's do some very simple things on this. For example, let's see how big are assemblies. Let's just take all the 6,164 entries and make a histogram to see what is the size distribution of our prokaryotic assemblies. It's already a kind of quality control of your data. If we see that, oh, we have 10 megabase and 15 and 20 megabase big assemblies, then something is wrong, because we know that prokaryotic genomes are rarely more than 5 megabases. There are some large bacteria, I think they can go up to 9 or 10 megabase, but usually they are between 2 and 5 megabases. So if we make a histogram from this column, we should see that. Okay, so we have this data in the SD_DF data frame. Let's start again with the ggplot. I want say again data equals 2 because the first parameter is usually the data frame. So I just say as the underline df. And what we will do now, it's just, there won't be any x and y because it's just a histogram. So we only have to give one column what we want to plot as a histogram. So what I want to give here is the size dot kb dot. So it came out with these dots. That's all. So that's the data frame we want to work on, and this is the part of the data frame we want to work on. And just say geom histogram and try it simply with this. So as you can see, we have some very small ones. We have quite a lot, around 2000 kilobases, which is 2 megabases. And we have another peak around 6 megabases, which is quite okay-ish. We have a few big ones, but it's not really significant. The reason why we have a cutoff here, because we actually throw away if there is any very small assembly. The small means smaller than 250 kilobases. But it's not really nice, this histogram. So first of all, it's we have a lot of data. So why shouldn't we use a bit higher resolution? So make the bins a bit smaller. And what you can do here is just simply say bins. I think it's as you can see here in my console, the default behavior is to define 30 bins. So if I say bins equals to 30, then I will have exactly the same graph. But if I say bins 100, so I want to see 100 separate bins, then we will have a much higher resolution and we can see peaks much better. If you think that you have a peak somewhere, what you can see, for example, if you think that there is something significant here around 7 megabases, but you cannot really see it because there is a huge peak here, you can do two things. You can limit your x-axis. I think it is done by, I hope. So for the xlim, you have to give a vector or not, we will see. Not just two numbers. Let's try with just two numbers, 4,000 and 8,000. Yeah, this is how it works. So of course, because I zoomed into that part of your plot, it will be stretched and extended, so you can see much better than, okay, we have a few dots here, but actually it's probably like 2 or 3 assemblies from the 6,000, or altogether these columns here, maybe like 10. This is the 10 line here. But don't do this now. Of course, here on the bottom left, you can see that there is a warning message that quite a lot of data points were removed from the plot just because I introduced some limits. Let me just leave it there and just make a new one here. The other way that you can use a logarithmic scale, it's not really nice to use a logarithmic scale with histograms, but it is possible. It's as far as I know, it's not really recommended. So don't put a logarithmic scale histogram into your papers. But if you just want to see something which you think is there, then you can use the logarithmic scale. And it's very, very easy. Again, you just have to say to ggplot that I want the y-axis to be a logarithmic y-axis, which is it's scale, I think scale y log 10. And it's of course way much more awful, but it's now a logarithmic scale on your y-axis. You can also use the density instead of histogram. I think it is just simply called geom density. It will be a smooth line which goes down with your distribution. Usually what you can see in many papers is that if you have a scatter plot in the middle, many people like to put a density curve to the top, which represents the distribution of these dots along the x-axis, and another here to the right, representing the distribution along the y-axis. We can easily do that actually, just to make something even nicer than this one. So let's plot our coverage and the GC content. This is how usually, if you don't have a high C metagenomics, what we do, but you don't have any idea what kind of bacteria you have in your complex microbial community, then you try to separate contigs based on their coverage and GC content. Because usually a prokaryotic genome has a typical GC content. The problem comes when you have, for example, a plasmid which was just taken up by that bacteria, which has a different GC content. It will be probably not assigned to that genome. Also, the coverage can be very different for a plasmid because you usually have multiple copies from a plasmid compared to a genome. So, which will come back in your sequencing coverage. If you put in 2 or 3 times more DNA from the plasmid than you put in from the genome, then your coverage will be 2 or 3 times more. But let's just make a scatter plot from the coverage and the GC content. So ggplot. We are using the same data frame, the SDDF, and we are working with mean underline cov and GC underline cont. And as a first thing, just simply do geom, which is the scatter plot. You always want to start with something like this and then go along all these fine tuning and colors and everything else later. So this is how it looks like. So first, what you can already see that we have some very high coverage assemblies, which means that it will bias the whole plot very much. So it's not really nice like this. So what we should do, in this case, there is a good reason to make the x-axis logarithmic, just to spread these dots a bit more. What I will do is I will make a scale x log 10, and it's already much nicer. And now, I mean, we can color them by clade, but the problem is that I think we have hundreds of clades. Just to show you that probably the same dots in the same clade will cluster together. So this is the clade. To find out how many clades we have, it's very easy because the clade variable, if you look at here the clade. No, it's actually an integer, it's not a factor. Nice. Okay, then just simply do it. Oh yeah, this is actually a very good thing that we will do this. So let's just say that color equals to clade. You can put this here, or you can put this here as well with the AAS. So what you see here, because as I showed you, the clade was put in to this column as an integer. So it will be a continuous scale, which is not really a good thing for us because there is nothing. So actually clade 97 is not closer to clade 133 than closer to clade 1000 something. So these are just numbers which came up as I put the assemblies into clades. But because it's an integer, the ggplot thinks that we want to plot something on a gradient scale, but we don't. So the way how you can change this is just simply make clade as a factor. So here we say as factor, as dot factor clade. Now watch out how many closing brackets you have. You have to have 3 here because you have to close the ggplot, you have to close the AAES, and you also have to close the S factor function. And it will be even worse now because all that few hundred color legends will be on our plot. Maybe it's struggling to do it. Yes, it is. Don't run it. If you run already, just say go here to your terminal or console and push Ctrl C. Yeah, it's hey, give me back my console. Okay, we were able to so the problem is that we have a legend which was just the gradient scale before, but now we have, because we have hundreds of hundreds of different clades. We have all of these is here. Okay, let's do a trick. Instead of trying to plot all of these clades, we will just plot the first few. So let's say that I will only plot up to clade number less than clade number 500. Okay. So what you can do here, that you can always subset your data frame. Say subset, which means that I will only work on a smaller part of this data frame, and I want to work only on those lines where clade is less than 500. Okay, so this is what will give me a condition. All the clades which have a number higher than 500 will be omitted from this plot, but the smaller ones will be here. And I think this will go much better, yeah. So here you can see that we only have this number of clades, even quite a lot we have. But as you can see, for example, here probably these pinks are from the same clade and these greens are from the same clade, and they are very similar with in GC content especially. These browns maybe are the same and these greens are also the same. So you can see at least some kind of clusterization with colors. We don't know if this blue and this blue are the same because the color scale is not really perfect. They are not very different from each other. You can, again, go to Color Brewer, but you won't really find like 50 colors which will be different enough. So if we just go down let's just go down a little bit with this 500 to 300. So we'll only have a few now. And as you can see now, the colors are diverging enough. So not the two greens, but if we have 2, 4, 6, 8, 10 different, then you can go to the color brewer. Is it here? Yes. And I can ask for 10 different colors. I can just copy the hex codes from here, and I will tell this that I want a scale color manual, exactly the same what we had before. The values will be equal to these things. Just replace the square brackets with normal brackets. There is something extra here. I think you can subset. If you have factors, you cannot say that it should be less than or more than. But I will tell you, yes, I will show you how. There is a typo probably here for me. This is closed. Oh yeah, it has to be a vector. No. It's not T here. It's just values. Yeah. So it's now much better. So you can see that these purple dots are very close to each other. These pinkies are not too close, but not too far from each other. The bright purple, which is a big clade, it's clearly having a very similar GC content. The bright green as well has a very nice GC content. The coverage in this case doesn't have to be similar because we are working with different samples. So it is completely valid that we have the same species in one sample with low abundancy, and we have the same species in another sample with much higher abundancy. Yes, go back to the factors. So we have here, for example, we have here CV. Let's make the same thing, but only with the assemblies from conventional farm 1. So actually, as you can see, farm ID is a factor. So what you can do is, and I will make it in a different line because I like this plot and I want to preserve it. So instead of saying that you want to subset your data frame by a threshold with clade number, you can just say farm ID equals to, and again, this is a double equal sign here, equals to CV 1, 1. This is only conventional farm 1, sample 1. I will show you how can you do it for conventional farm 1 for all the samples soon. So this is how you can do it, and hopefully, yeah. So we have quite a lot of different clades in conventional farm 1, but they are all here. But this is only one sample. What if I want all the 10 samples from conventional farm 1? There is no value in our big table at the moment, which would say that this is CV1. We can make a substring, and this is what we will do. And actually then we can go to the string manipulation. So just to show you a very simple thing, if you have a variable s, which is a string, hello, hello, and you use the substring, sub str s, and I think, let me just check quickly. I have the chat window here. Yeah, so what you have to give is just simply the start and the stop position. And in R, I think the string is numbered from 1. So if I just want to extract the first 3 characters, then I will say 1 and 3. And this is hell. Oh, if it's 1 and 4, then it's actually hell. Okay. So what we have to do with our table is that we want to extract the first 3 characters actually and use it as the farm identifier and not the farm and simple identifier together. I don't want to change this column because maybe we will need later on this thing. So I will introduce a new column into our data frame, which we put probably at the very end, what you won't see. And again, because R is a vector-based programming language, you don't have to do this in all rows. You just say the same thing, what we said here. So let's first list the column we want to change. So you can list that column by saying df, no, stdf dollar form ID. Okay, if you say this, then it will give you all the levels you have there. The problem is that we want to, that there are actually numbers, not strings in this case. So I'm not sure that the substring will work, but let's try it. Let's just simply try substring this thing 1, 2, 3. So from the first character on up to the 3rd character. It looks nice, but I'm not sure that it will work on, I think it will work, yeah. Okay, so what we want to do is just simply put this into a new column. So what we are doing is stdf dollar, and then we have to name the new color, which is just simply say farm without ID. Okay, this will be our farm identifier and not the farm and simple identifier. And I pushed enter instead of command enter. So if everything is true, we will have a farm somewhere. At the very end? No, we don't have it. I think the problem is because we are trying to change factors with substring, which is not working like this. So we have to list all of them. I think maybe let's just Google it. Okay, so we have to use this as dot character, probably somewhere here, as dot character. And we have now this here. So we have, at the very end, we have a farm column for our big table somewhere at the very end, where we only have the farm identifiers. So what we can do now, we can go back to our subsetting, and we can just say that we want everything from conventional farm 1. This will be a lot again, so make it a bit smaller. We can do multiple conditions for subset, but then we have to put it into brackets. This one, but here we are using the and sign. This one, only simple. This is usually meaning in many programming languages and this is meaning or. But in many programming languages, the and is actually a double, and or is also a double. No, or is just a simple. Yeah. But in R, both of them are just simple. So we are giving two conditions now. We are first of all filtering for the farm identifier, and we are also filtering for clades, and want to say that, okay, let's just have a clade less than 500 at this point. And we only have this many clade in conventional farm 1, but as you can see again, at least the GC content values are quite similar. We can go up maybe a little bit with the clade numbers to, let's say, 1000 to see a bit more. We will see some extreme clade. It's much more. But yeah, we have some clades up here, for example, with much higher GC content. I'm pretty sure that you cannot subset factors by saying something like this. So if your numbers are stored as factors, I don't think you can do this, because it's an arithmetic comparison, and I'm not sure you can do that. But I can imagine. We just don't have anything like that at the moment in this table. No, not here. No. Okay. Oh my God, it's almost 5. Okay, let me just show you the results of the third data set. Okay, let's import the third one, which was something like graph something. Graph data extended, okay? That was the third one. So again, as you can see here, we have a header in our file, and we have different columns. So in this case, are probably because before I also imported the data with header, now it is giving the header as well. Just import it. It will be the graph data extended variable. So this data is coming from a project where this is my part 2 student projects actually, which she was working on, and this was a collection of mastitis samples, so cows with mammary gland infection in the university cow dairy farm was analyzed, the sample was collected, and the infectious bacteria was cultured from these milk samples. And what you can see here, you have the cow ID in the first column. So of course you have the same ID several times there. Sometimes the quarters, so of course there are 4 quarters in the back left, back right, front left, and front right. They are quite separated from each other. So it's that was also a question in our project, if there is any cross infection between different quarters. This is the date when it was sampled and cultured. This is the sequence type. We actually identify the sequence type, and this is the position, which I will tell you what is it. Now, because we are quite running out of time, I won't go through all the steps we made to build up this graph. What you want to plot here from this data, is how the infection appears or disappears with time. So you will have a time dimension that will be the x-axis, where you have the different months between 2008, I think July or August was the first, and then 2009 somewhere in the same, like May or June was the last one. So you will have different time points. And on the y-axis, you would try to separate the cows, but you also try to separate their different quarters, because you want them plotted separately. And this is what the position will do. So the whole data was pre-processed, of course, with some kind of script before. And if you see the same position 44 here, the 44 means that it's always the same cow and always the same quarter. But if you go down and see, okay, this cow has a front right quarter as well, it will have a different position. So if we just plot these as dots, it's already not bad. But I will show you how it looks really, really good, and I will tell you the whole story, how we can build up it to make it that nice as it is at the final stage. So if we just say ggplot, graph data extended, this is our data frame. And we are putting the date, I think it is called date, yeah, to the x-axis. We are putting the position to the y-axis, and we are just making a simple geom point plot. It's not POS, it's PO. Oh, it's POS, but it's all caps. Then you will see something like this. It's not very informative at the moment. There are many different problems with this. So first of all, I think the data is not really good. Yeah, we know that we didn't have any data from February. So at the moment, R and ggplot handles the date as factors. So as you can see here, there is one tick or one unit of distance between March and April. But there is also 1 unit of distance between January and March, which is not good. There should be an extra gap here. But just because we didn't have any data points from February, February wasn't put on the graph. So the first thing what we will have to do is to convert these strings, which are dates for us, but not dates for the R and ggplot, to dates. And because we are running out of time, I will open and copy here this huge amount of thing, and we'll go through all steps separately. Okay, it starts almost the same up to, let's say, here. Okay, so what we have here is the same. I just say that, okay, let's handle date as date. Okay, I'm using position the same thing on the y-axis. You will see why later on. And I also introduce a color here because we have sequence types. So let's color them by sequence types. And then the GM point just take a different shape and a different size, but it's not important at the moment. But just by doing this, first of all, we have colors by sequence type. We know that we have 5 different sequence types from this bug, which is a Staphylococcus chromogenes bacteria. We can already see that certain sequence types are in the same kind of height, which is good because this is probably the same cow. We don't know yet because it's not annotated on the plot yet, but at least we can see that, okay, this plot is the same. The only reason why we have different type of shapes is that we also give this shape here, and we define the shape as a factor from the quarter. The quarter is, you know, is the thing which is back left, front right, front left, and so on. So all, and as you can see, all the back left quarters will be circles and triangles, the back right, and squares for front left, and this cross from the front right. The problem is that it's not. It looks like it's not continuous, and I wanted to make it a bit more like a line, but only line where we think there was an infection. So if we have an infection in January, let's make it a dot there, but also put a horizontal line together with the dot, showing that this was actually probably a continuous infection or a longer term infection. This is what we will do in our next command here. So what we are doing, we are giving an error bar. You can define error bar horizontally, vertically. The problem is that the data which is needed for the error bar is not here yet. So what I did before, I actually just simply subtract 15 days and add 15 days to our date. So make it like a 30-day long period, which is maybe not true because we only have one sampling time, but it looks better. So the way how I did it, and this is again not really. It will be on the Google Drive, the whole thing, so you can just follow it. But this is how the whole time thing will be changed. So this is where I actually subtracted 15 days, which is in this case, it is in seconds. And then I did also 15 days in seconds to that. So from this moment, we can have a horizontal error bar. So it will be like this. The reason why I have, so if you have an error bar, you have to define what is the minimum and what is the maximum of the error bar. And also there is a height here, which is 0 because ggplot is making flat-ended error bars in default. So if I change this to 3, I think in default it's maybe 2 or 3. If I change this to 3, then it will become a real error bar with a flat end. Of course, I didn't want to do this. That's why it is 0. Okay. I changed the scale, I think even here. No, okay, here you can see that there is no February. So now the date is working well. There is a nice gap because we didn't have any samples from February. But for some reason, I did this. I don't know if there will be any change after I say this. I don't think so, but maybe. Let's just go back. With this arrow, you can always go back to the previous plot and see if there wasn't any change. Probably it just remained there. And then I introduce horizontal lines. You can always put in horizontal lines, vertical lines, any kind of lines. If you want to put in, for example, a diagonal, and you want to show your scatter plot compared to diagonal, it's very easy to put in, but you can also put in horizontal or vertical lines to your plot if you want to separate things from each other. Of course, I would like to separate the different cows in this case. So these lines will separate the cows. It's not nice at the moment, but it will be much nicer later on. The way how I did it, so if you want to introduce a horizontal line, you have to give where it should intercept the y-axis. Instead of just giving one, this is what I did. So I actually made a sequence from 6.5 up to 125 with a step of 6. So if I just copy this here and run, these are numbers which are increasing by 6 every time. And this was a nice distance for me. So between two gray lines, you will have one cow at the end. Okay, I won't copy this again. I didn't like the grayish background, so I choose the theme black and white. So it became black and white, much better. Instead of using the built-in colors of the artist pinky and cyan colors, I already defined my color palette, which came from, of course, from the color brewer. But this is not a simple vector, this is a name vector. So for 1, I want to use this color. For 2, I want to use this color. For 3, and 1, 2, 3, 4, and 5 are actually the sequence types of the different bacteria. So if I'm using this in my scale color manual, this is again exactly the same what we used before. So instead of using the default color palette, I am using my own values. The reason why I wrote sequence type here, because this will change the legend text. Instead of saying as.factor sequence underline type in brackets, which is ugly, it will be simply sequence type. I think I ran my call. There is something wrong here. Probably this is something like this. And you push the brackets or anything like that, it will just put into, so even quotation, instead of writing quotes in the beginning and at the end. So if I want to do, for example, on this one, it is very easy to put into quotation. I think this is the problem, but I'm not sure. Yeah, I think this is the problem. This was the problem. Okay, so now we have much nicer, much more diverging colors on our graph. And I, of course, change the labels because, again, I don't want a pos and as date in brackets as my labels. So xlab and ylab. And then all the next things from here up to there, it's all about changing okay, Hannah. Sorry, yeah, it's a bit late. It's 5. I will finish in 5 minutes. See you next week. So all these things are just about getting rid of the extra lines, getting rid of these numbers because I won't need the Y text, making them a bit larger. So as you can see, these are much nicer. We don't have any extra gray lines here. We have these numbers here, but they will be removed later here. Okay, so this one is copied there. So this one was used to make a new X label, X text. So instead of having the numbers here, I replace them with the cow IDs. It isn't changing. Oh, yeah, I didn't copy the whole line here. The limits. So now I have the cow IDs there. And I think in the very end, I just replace the shapes. And instead of having BL, BR, and FL, FRI right there, that it's back left or back right. So that's the final graph for this one. You can see that, for example, cow number 112 in front left quarter had an infection from this date up to here. Probably here it was infected as well, so it was a persistent infection, but there wasn't any sampling in February, and it was the sequence type 1. So now you can ask questions, for example, like, is there any infection between the quarters? If you see 118, yes, it seems that the same sequence type, the same strain infected different quarters. But if you look at 128, 3 completely different strains, even at the same time, 2 different strains, 2 different sequence types was in the same, exactly the same cow. And these are really, really very different strains. So the sequence types are very different from each other. Also, we try to find infection which is going from one cow to the other. So for example, if this one which was persistently infected, did it spare the infection? Do you see more rats? Yeah, the rat is appearing here and here and here and here as well, but it's not really convincing. So at this at the end, we just concluded that we need, of course, way much more data than this. Right, I will finish here. We didn't have time for too much of the string manipulation, so I will come back to that thing maybe next time, or if we will speak too much about data handling on Tuesday, then next Thursday. Is there any questions?